Okay, let's continue from this example. This example is about we have an address from a port, we have a data from another port. This data will be written to the address pointed by port, the other port. Data and address value obtained by the switch from the external world. Let's do this question today. Port 1 has a data and port 2 has an address, 8-bit address. Let's do this question now. First of all, we have to get address value, and for this question we have to use indirect addressing because the related data will be written to the address. Address value, it's mean indirect addressing for us. So we have to use R0 or R1. I select R1 for this question, and address value will be obtained port 2, yes. Okay, then we should get the data to another register such as A, move A, port 1, and after that move at R1 at R1 A, and that's all, I think. And also this data should be written to the port 3 for this question, as I remember. Yes, also the same data will be written to the port 3. For this question, first of all, we have to assume a address value and we have to write a data from the related address before, because for this question we obtained a data and address value from the port 2. How can we do it? We can do it with hardware or software. Let's do it with the hardware. It means we can do it with a switch. We can assume as like that. Yes, build this program and we have no error and no warning. Let's go to the debug session part. First of all, we need to port 1, port 2 and port 3 for this question. We have to get them from the peripherals tab. Let's get it. And also port 3. Yes, now we got it. From port 2 we'll get an address value. Assume that this address value is 0fx. For example, we have to assume another port as data. Let's assume it as bfx, for example. Let's assume it is bfx according to the position of the switch, and port 3 has the ffx value, which is a default value for all ports, as you know. Yes, we are in line 2 as champ X. Let's execute the program step by step. If you click one more time to step, we'll get R1 as port 2. What is the port 2 value? 0fx. 0f is an address value for the question. Yes, it is 0f. Where is R1? Bank 0 is selected as a default, so R1 will be 01 hex address. And we will get a data value from the port 1. As you see here, port 1 has bfx value and A is 00 value. Now A is bfx. After this comment, we know this 0fx address, 0fx address will be bfx value. Yes, where is 0f? The end of this line we have 0fx address because the next memory cell will start 10 hex, so it should be 0fx. As you see here, 0fx address has bfx value, which is obtained from the port 1. And also the related data should be written to the port 3 with the line 6. Let's do it now. Yes, port 3 has bfx value now. If you do this program continuously, if I asked as this way, so we can modify the program with only sjump command. Sjump will go to the X label. If we do it, the program will continue to work as like that. Let's build it and try this program now. We are in debug session part again. Port 2 is address value. Again, assume 0fx address. It is bfx value. Let's execute this program. Now, as you see here, the same program, and sjump x will go to the line 3 again. Assume that the address value is changed, such as 1fx. It is in here in the data memory, as you see, and the data is also changed, such as behex. Okay, let's do this program again step by step. We will get the address value from port 2, R1 now 1fx, and we'll get the data value from port 1, which is behex, and it is in A, as you see, and it is written to the related address, as you see, and also the value will be written to the port 3. Okay, maybe we can try another address, such as 2fx and bdhex, assume it, and we can continue as like that, bf, be, bd, we can continue as like that. Okay, in here we used another program commands. Maybe we can try this program. In here we have another solution. Yes, I have to arrange this program, sorry. Okay, we don't need to consider the cleaning low RAM areas, so we can erase this part in the program. Okay, we don't need to use toLabel for this question again, so here we can use xx1. We don't need to xx2 label. What's more, yes, the same question will be done with another way. What is the difference between them? Only you can see the address value of the R0. It is only difference for this question. We used R0 or R1, but here, as you see, the address value of it will be used. Okay, maybe you can confused in this line. Let's build this program. We have no error and no warning. Let's go to the debug part. Okay, again we need to use ports. Maybe we can get only port 1 and port 2. It is enough for us. We have already understand the question. Let's get the same value, which is BFX and 0F. Maybe we used, yes, 0FX we used. Port 1 will be written to the A. Port 1 has a data and A has the same data, which is BF. And in here, port 2 will be written to the 00 hex. What's mean? In the RAM, 00 hex address is R0 in the bank 0. Okay, so you can use here R0 or 00 or byte address of the R0. It is not important. So here R0 is 0FX, and as you see here, the register value of the R0 is 0FX. Now the same data will be written to the 0FX address. Okay, as you see here, the same data is written to the 0FX address. Okay, that's all. There is no another difference between the program. Assume that we have a question starting from 1FX to the 00 hex. How can we done the related address as BE hex value? Okay, the question is that. So we have to write R0, the value is 1F, which is the address value, starting address value, and then we have to continue indirect addressing mode for this question, so we don't need to line 4, R0, and what is the value? BE hex. So we have to use diasis sign 0 BE hex. After this command, 1FX address will be BE hex value. Okay, and we have to use here DJ and Z commands R0, and if it is not 0, it will continue. We have to use new label such as X1, and program will go to this line. After all process, R0 value will be 0 because, as you see here, this command is working as like that. So if you do 00 hex address as also BE hex, so you have to write here move R0 BE hex. Okay, let's try it. If you build this program, we have no error and no warning. Let's go to the debug session part. We don't need to use ports. Yes, R0 now 1FX address and written to the BE hex to the 1FX address, and R0 will be 1E after the next step. And if you click again and again, you can see the memory changing on here. You can follow the values as like that. Yes, in this step, as you see here, R0 is 0, 1. So we will write the BE hex to the 0, 1 hex address. What is next? R0 will be 0, 0 hex. So this condition is not satisfied anymore. The program will continue with the next line. Okay, let's try it. Yes, 0, 1 hex address will be BE hex. After this comment, the program will continue with the line 6. Yes, as you see here, 0, 0 hex address has 0, 0 value. So we have to write also BE hex to the R0. Okay. Chapter 5, 1851 instruction set. In here, move command we used before many times, so I prefer to continue with the data processing commands, which is ANL or L and XRL. As I said in the lecture, these commands are used for the masking. Let's do this question, this example now. Quit the debug session part and let's write a value to the PSW such as 0 FFX value, and we want to change bank value as 0. If it is different, we don't know yet. Okay, but we want to select bank 0 for this question. However, we don't want to change the other bits of the PSW. Okay, we don't want to change the other bits of the program status word. So how can we do it? We will use ANL command for the bank 0. Okay, selecting the bank 0. In here, what is PSW? Now 1111 binary value. We want to change it as 110011 binary. Okay, the third bit and fourth bit of the PSW will be 0 for the bank 0. Okay, how it is possible? First of all, we have to check ANL command usage. As you see here, ANL command can be used with the A or direct address for the destination. First of all, we have to think about PSW, program status word. Where is it in the RAM? PSW is in SFR area. Okay, SFR area, special function register. So we can accept PSW as direct address. If we use PSW as direct address, so we can directly use this command. Okay, let's do it. ANL PSW, and the data is 11100111 binary, and that's all. We don't need to write another code for this question. Let's build this program. We have no error and no warning. After this comment, bank 0 is selected. without changing another bits of PSW. Okay, let's go to the debug session part now. We don't need to use port. Yes, we can see the PSW here. Okay, here. Also, we can check the PSW in the data memory. For the ports, all ports, we have FFX value here. Port 0 is in 80 hex address, port 1 90 hex, port 2 A0 hex, and port 3 B0 hex. If we click line 3, if we execute line 3, some of the memory cell in here will be FFX because we assumed PSW is in SFR area. Okay, maybe we can check it. Yes, SFR area is starting from 80 hex to FFX. Okay, and we have no FFX value besides the ports, as you see. Let's check it. We are in line 2 SJump XX1. If you click one time, we are in line 3. If you click one more time to line 3, PSW will be FFX. FFX, yes. Where is it now? Okay, as you see here, PSW is in D0 hex address, but it is FE hex, not FF hex. What is the reason? It's about the parity bit. Parity bit is about the accumulator. According to the accumulator value, parity bit will be changed. Okay, so even though you write a value to the PSW, some flags behave according to the other operation. Okay, so parity flag will be 0 because of the accumulator value. So here we has PSW, and after this command, PSW value will be what? 8 plus 4, 12 plus 2, 14. It's mean E, I think, and the other part is 7, E7 hex. But because of the parity bit, it will E6 hex, I think. Let's check it. Okay, as you see here, PSW has E6 has now E6 hex value now in this part. Okay, PSW has E6 and we select the bank 0. How can we know? We can check it with the RS bit here. It is 0. Okay, if you want to select bank 3 without changing the other bits of the PSW, how can we do it? We will use OR command or L command, as you know. Assume that here we used OR and the other bits of the PSW will be 0 and RS0 and RS1 will be 1, 1. To select the bank 3. If you do this process, this command, what will be happen? PSW is FFX and we didn't change the des bits and des bits of the PSW. Why? we have to know OR operation. If you OR any number with the other number with the 0, the number is going on. But if you if you do OR operation with the number 1 and with another number, the result will be always 1. Let's build this program. Build it, and we have no error and no warning. We'll go to the debug session part, and let's try to get PSW is FE hex. As you see, without changing the other bits, PSW value will be the same, right? Because it is already selected bank 3. If you click PSW here, you can see RS is 3. It means bank 3 is selected because of this value. So doesn't affect this value, this comment to the PSW. Yes, as you see here, PSW does not affect it from this comment. Maybe we can change the PSW before. Quit the debug session part and write 00 hex to the PSW. And then with this comment, bank 3 will be selected. So PSW value will be 18 hex. Okay, let's debug. Let's build this program. Okay, we have no error. Let's go to the debug session part again. Okay, we are in line 2, step, and as you see here, PSW is 00 hex, and also or LPSW with this number, bank 3 will be selected. Yes, here we can see, yes, bank 3 is selected, and the new value of the PSW is 18 hex. Yes, clear and complement command, we can use this command with only accumulator, and we have also arithmetic operation. Maybe we can select bank 2. How can we do it again? We want to change bank without changing the other bits of the PSW. We want to select bank 2. How can we do it? We will use two commands. First of all, maybe we can write ffx value again. First of all, we can use ANL PSW and 00 111 00111. It means bank 0 is selected. Both of the bank selecting bits will be 0 after this comment. And then if you want to change as bank 2, we can easily apply this command, and we can change the bank with this comment. Okay, after this comment, we don't need to know PSW value. Let's try it. We have to quit debug session part before and build the program. Let's go to the debug session part. We can check the selecting bank from RS. Yes, now after the line 3, bank 3 will be selected because we write ffx value to the PSW. And after this comment, bank 0 is selected because RS0 and RS1 will be 0. After this comment, bank 2 is selected, RS is 2, because RS1 will be 1 after this comment. That's all. Clear A and complement A. Let's do another example about these comments. Move A, diasis sign, 0F E hex, clear A. Move A, maybe we can use, first of all, complement A. We said before we can use this comment only with A for the byte operation. Maybe we can try for R0. Okay, what will be happen now? With this program, invalid register error, as you see here. If you click 2 times, the related error line will be in here. Maybe we can try direct address 10 hex. What will be happen now? We have no error. Okay, we can use clear comment A for the byte operation, but we can also use the clear comment for bit operation with a bit address and also carry flag. Okay, if you write this program 10 hex, it is understood as it is bit address, okay, not byte address. So we can clear now. Okay, let's check it now, and we will go to the debug part. We are in line 2. After the line 3, A will be FE hex. After the complement, what will be happen? Let's try to A value before. F means 1111, E means 1110, right? After the complement, the each bits of the A will be complemented 0000, 0001. So it will be 1 hex. After the clear A will be 0. Let's try it. Yes, after the complement, A is 01 hex. After the clear, A is 00 hex. Okay, that's all. Thank you for your participation to the lecture.